You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your Cloud Plus certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. Cloud network services that control access and enforce security policies include a wide range of virtualized tools that replicate the behavior of traditional perimeter security appliances. Among the most critical of these are firewalls and web application firewalls, often abbreviated as WAF. These technologies are designed to inspect traffic, block unauthorized requests, and allow only safe communications into and out of cloud infrastructure. In the context of the Cloud Plus certification, understanding how cloud-native versions of these tools are deployed and configured is essential for securing both application and infrastructure layers. Firewalls and web application firewalls remain critical in cloud environments despite the changing nature of infrastructure and the abstraction of physical hardware. Even though cloud environments are software-defined and highly dynamic, they are still exposed to the internet, and workloads still process untrusted input. Traffic filtering, protocol inspection, and request validation are just as important in virtualized systems as they were in on-premises data centers. Candidates preparing for this certification will encounter questions that ask how firewalling and WAF services reduce the exposure of cloud services to unauthorized or malicious requests. A stateful firewall inspects each packet not only in isolation but also in the context of an established session. It tracks active connections and allows return traffic only if the original outbound communication was authorized. This behavior helps reduce the complexity of rule sets, as only the initiating direction needs to be specified explicitly. In infrastructure as a service environments, stateful firewalls are often integrated into virtual network configurations to protect individual virtual machines or entire subnets. The certification includes topics on how stateful inspection maintains secure and efficient communication in dynamic workloads. A stateless firewall does not keep track of session context or connection history. Instead, it evaluates each packet as a standalone event, applying rules based solely on attributes like source address, destination port, and protocol. Because of this, stateless firewalls require explicit rules for both directions of traffic, including request and response. While this increases rule complexity, stateless firewalls are faster and are often used in edge deployments or high-throughput environments. Candidates must be able to recognize where stateless filtering offers performance advantages and how to compensate for its lack of session awareness. Choosing between a stateful and a stateless firewall depends on the use case and the architectural requirements. Stateful firewalls are better suited for protecting internal applications and services, where session tracking improves security and simplifies rule creation. Stateless firewalls are often deployed at the network perimeter, where high performance and protocol-agnostic filtering are required. The exam may provide traffic patterns or policy objectives and require the candidate to determine which firewall type offers the best balance between control and efficiency. Many cloud platforms organize firewall rules into constructs like network security groups or security lists. These logical containers group rules and apply them to virtual machines, subnets, or interfaces. Network security groups define inbound and outbound permissions, and security lists enforce traffic behavior at the packet level. Cloud providers offer native interfaces for managing these rules, and the exam may include scenarios involving misconfigured rules in a network security group that result in blocked or overly permissive access. A web application firewall is a specialized type of firewall that focuses on inspecting HTTP and HTTPS traffic to detect and block application layer attacks. Unlike traditional firewalls that work at lower layers of the network stack, WAFs understand web traffic structure and can identify threats such as structured query language injection, cross-site scripting, and malformed headers. These threats specifically target web applications, and the exam will test a candidate's understanding of WAF functionality in cloud-hosted environments. Web application firewalls can be deployed in multiple architectural models. They may operate inline, directly inspecting traffic as it flows between the client and the application. Alternatively, they may act as reverse proxies, terminating the connection and forwarding valid traffic. Some are offered as a managed service by cloud providers and sit in front of load balancers or application gateways. Candidates must understand which WAF deployment model fits a given scenario, including how each option affects latency, scalability, and policy enforcement. WAFs support both static and dynamic security rules. Administrators can configure allow lists, block lists, and rate-limiting policies based on expected traffic behavior. WAFs also include signature-based rule sets that detect known attack patterns, and many services allow dynamic updates based on threat intelligence feeds. The exam may describe an application under attack and ask candidates which WAF policy or rule type would block the traffic without affecting legitimate users. Logging and monitoring are critical for all firewall systems. Logs must record permitted and denied traffic, anomalous activity, and system-level events. These logs support incident detection, forensic analysis, and compliance audits. Monitoring tools should consume firewall logs and alert administrators to abnormal traffic patterns or rule violations. Cloud Plus includes firewall logging as part of its operational focus, and candidates must be able to interpret log behavior and identify misconfigured or ineffective rule sets. Firewall rules are increasingly defined through automation. Infrastructure as code platforms allow security policies to be deployed alongside workloads, ensuring consistency and reducing manual errors. Policy engines can scan firewall rules to detect drift or unauthorized changes and enforce baseline configurations. Candidates preparing for this credential should understand how firewall lifecycle automation works in practice and how it helps maintain a strong security posture in evolving cloud environments. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Firewall rule evaluation follows a strict top-down processing model. Rules are assessed in order, and the first match determines how traffic is handled. This means that more general rules placed above specific ones can inadvertently block or allow unintended traffic. Misordered rules can expose sensitive systems or silently disrupt service connectivity. Candidates must understand how rule order affects policy outcomes and be able to debug configurations where the effective behavior does not align with the intended policy. Many cloud firewalls use an implicit deny model, where all traffic is denied unless explicitly allowed by a defined rule. This ensures that only authorized traffic is permitted and minimizes exposure to misconfiguration. However, relying on implicit behavior without defining complete allow rules can result in necessary services being blocked. On the exam, candidates may be presented with a scenario involving denied access and asked to identify which required allow statement is missing from the configuration. Application-aware firewalls operate at a higher level than traditional packet filters. These tools can inspect traffic based on the application layer protocol, or even the content of the payload, regardless of which port it uses. This enables enforcement of more specific security policies, such as blocking certain file types or restricting access to known risky applications. The Cloud Plus certification may ask candidates to choose the correct firewall type when an organization needs to block application behaviors that do not conform to predictable port usage. In modern cloud environments that rely on containers and microservices, traditional firewalls are often insufficient. Internal communication between services can bypass perimeter controls entirely. In these cases, security must be integrated with container orchestration systems and use identity or tag-based rules to enforce traffic segmentation. Cloud Plus includes questions that test awareness of container-aware firewalling and the need to extend security policies into dynamic, internal service meshes. Firewalls and web application firewalls often incorporate rate-limiting features to protect against denial-of-service attacks. These controls restrict how frequently requests can be made, either per user, per session, or per endpoint. This is especially useful for mitigating low-volume attacks that evade traditional signature detection. Candidates must know where to place rate limits for optimal impact and how to configure them without interfering with legitimate traffic. Logs generated by firewalls and WAFs are most useful when integrated with centralized monitoring systems like security information and event management platforms. These systems correlate firewall data with application, system, and user activity to detect complex threats. Cloud Plus may include questions about configuring log destinations and using event correlation to detect security incidents that would not be visible from a single data source. Firewall policies should be audited and reviewed regularly to prevent rule sprawl, detect unused entries, and identify overly permissive configurations. Change logs should track who created or modified rules, when changes occurred, and what justifications were provided. Over time, unused rules can clutter the policy set, making it difficult to manage and increasing the chance of errors. On the exam, candidates may be asked how to identify which firewall rules should be removed or revised to improve security posture. In summary, firewalls and web application firewalls continue to play a vital role in securing cloud environments. They filter traffic, enforce segmentation, block attacks, and enable monitoring. The combination of stateful inspection, application layer controls, logging, and automation supports a comprehensive defense strategy. Candidates pursuing this certification must know how these tools function, how to configure them correctly, and how to adapt their use to evolving architectures and cloud-native technologies. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.